Hey, space explorers! Today we're diving deep into one of the most mysterious and dangerous objects in space, the black hole. You've heard the name, maybe seen it in movies or documentaries, but do you really understand why they're so dangerous? Welcome to Interstellar Quest, where we journey through the cosmos, uncovering the universe's most mysterious and mind-blowing phenomena. By the end of this video, you'll know exactly what makes black holes so deadly, how they form, and what would happen if you ever got too close. So sit tight and let's embark on this interstellar adventure. But first, hit that subscribe button and ring the bell so you never miss an adventure like this. Imagine a region in space so powerful, so dense, that not even light can escape its grasp. A place where time, space, and the laws of physics are twisted beyond recognition. This is what we call a black hole. But what makes them so dangerous? And why should we care about them? Buckle up, because we're about to dive into the unknown. All right, but first, what is a black hole? Let's break it down. A black hole is essentially a region of space where gravity is so intense that not even light can escape. You may be wondering, how could something so invisible be so dangerous? Well, that's the paradox of black holes. We can't see them directly, but we can observe their effects on the things around them. You've probably heard the term event horizon. That's the point of no return, the boundary surrounding a black hole. Once something crosses the event horizon, there's no coming back. Light, matter, even radiation are trapped inside. And here's the kicker. Nothing can escape from this point. Let's understand how these monstrous black holes form. Black holes are born from the death of massive stars. When these stars run out of fuel, their core collapses under its own gravity, creating a singularity, a point of infinite density. The outer layers of the star may explode in a violent supernova, but the core remains, becoming a black hole. But here's something exciting. Thanks to recent discoveries, we now know that black holes can also form in other ways. For instance, scientists believe primordial black holes could have formed in the early universe, just after the Big Bang, from dense regions of matter. Imagine all the mass of the star crushed into a single point. That's the singularity, and it's surrounded by the event horizon, the point beyond which not even light can escape. So, dangerous, right? But it doesn't stop there. Black holes come in several types, each with its own level of danger. The three main types are stellar black holes. These form when a massive star collapses. They typically have a mass anywhere from 3 to 10 times that of our Sun. Supermassive black holes. These giants reside at the centers of most galaxies, including our own Milky Way. They can be millions, even billions of times more massive than our Sun. The one at the heart of our galaxy, called Sagittarius A, has a mass of around 4 million times that of the Sun. And just recently, astronomers captured the first ever image of the shadow of a supermassive black hole at the center of the galaxy M87, a breakthrough in astrophysics. Intermediate black holes? These are still shrouded in mystery, with masses ranging from 100 to 1,000 solar masses. Some recent discoveries, including the detection of gravitational waves, hint that intermediate black holes may be much more common than we thought. Each one is a gravitational force to be reckoned with, but the real danger comes from their effect on their surroundings. Let's talk about that. What do you think would happen if a planet or a star ventured too close to a black hole? It's not pretty. As you get closer to the event horizon, the tidal forces, the difference in gravitational pull, become stronger. Eventually, these forces stretch and distort objects in a process known as spaghettification, and it's as terrifying as it sounds. If you were unfortunate enough to get too close to a black hole, your body would stretch into a long, thin strand, like a piece of spaghetti, and be torn apart atom by atom. It sounds crazy, but it's true. And if something, like a star, gets too close, it'll be torn apart and consumed by the black hole. Poof! Gone forever. Now, We can't talk about black holes without mentioning some of the more outlandish theories about them. Some people believe black holes are portals to other dimensions, or that they could lead to wormholes that provide shortcuts through space. One theory even suggests that black holes could be gateways to alternate universes, which sounds like science fiction, but isn't entirely outside the realm of possibility. After all, black holes represent regions where the laws of physics break down, and we really don't know what happens inside them. But what do you think? Do you buy into these theories, or do you think black holes are just cosmic death traps? Let me know in the comments below. So, why are black holes so dangerous? The sheer power they wield, destroying stars, bending space-time, and trapping everything in their grasp, is just part of the story. But they also represent the most profound mysteries in science. From how they form to what happens inside, black holes could hold the key to understanding the very origins of the universe, and even the fate of space itself. They're powerful, unpredictable, and can tear apart anything that ventures too close. But they're also part of the very fabric of the universe, offering us clues to some of the most profound questions about space, time, and even the origins of the cosmos. They could be a window into the secrets of dark matter, dark energy, and quantum physics, bridging the gap between general relativity and quantum mechanics, two of the greatest unsolved puzzles in physics today. But don't get too comfortable near one. And now, you know why. Because now you know how dangerous it can be for a star to be close to a black hole, then just think what it can do to a normal human being in a spaceship. We've just scratched the surface of these mind-bending cosmic giants. If you're ready to continue exploring the mysteries of space, be sure to subscribe to Interstellar Quest and hit that notification bell so you never miss an adventure through the cosmos. And, of course, leave your thoughts in the comments below on what do you think happens inside a black hole. Do you believe any of the conspiracy theories about them? Let's keep the conversation going. I'll be reading everyone's comment and respond with what my thoughts. Let's start a conversation, and maybe, just maybe, the next theory can be from us. Share this video with your friends who are curious about the mysteries of space, and let's keep expanding our interstellar community. Imagine this. You're floating in the endless darkness of space, surrounded by the vast, infinite universe. And suddenly, a chilling thought creeps into your mind. What if our Earth was pulled into one of the most terrifying, mysterious objects in space? A black hole? Not just a random cosmic event, but our planet, our home, dragged into the gravitational abyss. It sounds like something straight out of a science fiction movie, but it's not. It's a terrifying reality. So what would happen if Earth were to get trapped inside one of these cosmic monsters? Well, buckle up, because we're about to explore the terrifying consequences of getting too close to one of the most powerful forces in the universe. Before we jump in, let me know in the comments, what do you know about black holes? Are you ready to face the terrifying truth, or is your mind already blown? Let's get started. Okay, let's break it down. It's black holes. These are not just mysterious objects in space. They are monsters, cosmic beasts with an appetite so vast that not even light can escape. And if light can't escape, that means anything else, anything, is doomed the moment it gets too close. Imagine this. You're walking down a path, and ahead of you, you see a hole. But this isn't just any hole, it's the ultimate hole, a place where the laws of physics break down. That's what a black hole is. It's a region in space where gravity is so powerful, it warps time itself. In fact, as you get closer to the black hole, time starts to slow down. Seconds might feel like hours, or even centuries. Think of it like this. Imagine you have a vacuum cleaner, but this isn't your ordinary vacuum cleaner. This one can suck up everything around it, even light. That's how strong the gravitational pull of a black hole is. And this vacuum cleaner is hidden within a space that we call the event horizon. The event horizon is the point of no return. Once something crosses it, there's no coming back. You might be wondering, what's on the other side? Well, there's the singularity, the very center of a black hole, a place where all the mass is crushed into a single point, a point with infinite density and gravity. You can't even imagine the forces at play here. Anything that gets too close to it is stretched, crushed, and torn apart by forces beyond comprehension. If you ever wondered what it's like to be torn apart by space itself, that's what happens at the heart of a black hole. So, how do these cosmic monsters form? Well, it all starts when a massive star runs out of fuel. It begins to collapse under its own gravity. This is known as a supernova, a catastrophic explosion. But here's where it gets horrifying. For the largest stars, that explosion isn't enough to stop the collapse. The star continues collapsing and collapsing until it becomes a black hole. Imagine a star hundreds of times larger than our Sun, collapsing into a point smaller than a speck of dust. A supernova explosion so violent it shatters the very fabric of space. Then, in the aftermath, all that's left is a black hole, swallowing everything in its path. Can you even imagine the sheer force required for a star to collapse like that? And to create a supermassive black hole that devours entire galaxies? It's enough to make your skin crawl. Now, the big question. What would happen if Earth, our precious blue planet, got pulled into a black hole? Let's take this journey step by step. As Earth moves closer to the black hole, the first thing you'd notice is the intense gravity. It starts off slow, almost imperceptible. But then, it gets stronger and stronger and stronger. As we approach the event horizon, everything would begin to stretch. Everything, from the oceans to the atmosphere to the very ground beneath your feet. Earth would start to elongate, pulled into a long, terrifying shape. We call this spaghettification. But it's not just some fun word. It's a nightmarish process where the planet is stretched out like a piece of spaghetti, torn apart by the black hole's ravenous gravity. But that's just the beginning. As we get closer, time itself begins to behave strangely. It starts to slow down. Imagine looking at a clock and seeing the seconds stretch into hours, then days, then eternities. From the outside, Earth would look frozen in time, as if we're suspended in a horrifying cosmic limbo. But from the inside, it's like watching the end of the world in slow motion. Now picture this. You're still on Earth, feeling the immense stretching force as you get pulled in. What would that feel like? Can you even fathom the sensation of being pulled apart piece by piece? Would you survive the journey? Or would everything, everyone, be lost to the abyss? Let's venture into the unknown. Some scientists believe black holes might be gateways to other universes, what we call wormholes. Imagine passing through a black hole and suddenly finding yourself in a completely different universe, or even in an alternate dimension. Scary, right? But there's a catch. No one knows for sure. It's all just speculation. And then Hawking radiation, an eerie concept that suggests black holes could slowly evaporate over billions of years. But what happens to everything inside? Does it vanish forever? Or does it get spit out somewhere else? What do you think happens? Could black holes actually be portals to other worlds? Or are they simply the ultimate graveyards for everything that dares to venture too close? I'll leave that question for you to ponder. So there you have it, the terrifying reality of black holes, the crushing force, the endless pull, the slow, agonizing destruction, and we've barely scratched the surface. If you're still not shaken by the thought of these cosmic giants, then you're a braver soul than I am. But I want to know, what do you think? What would happen to Earth if we got pulled into a black hole? Is there any chance we'd survive, or are we doomed from the start? Let me know in the comments. I'm dying to hear your thoughts. If you found this mind-blowing or terrifying as much as I did, make sure to hit that like button, share this with your friends, and subscribe for more mind-bending content.
Imagine waking up in the morning. You stretch, yawn, and glance out your window. The sky looks wrong. There's no familiar golden glow. No warm sunlight spilling across your street. Instead, there's an unnatural darkness, an eerie shadow engulfing the horizon. What if that darkness wasn't just a thick cloud or a power outage? What if it was the beginning of the end? A black hole, invisible and merciless, drifting silently toward our sun. And right now, it's beginning to swallow the very star that gives us life. Can you feel it? The cold dread creeping up your spine as the reality sinks in. The sun, our fiery, radiant life source, gone. What happens next? How does the world respond when the source of all light, warmth, and energy disappears in an instant? Would you fight to survive? Would you look for hope? Or would you simply stare into the abyss? Before we face this cosmic nightmare, let's take a moment to understand the star at the center of it all, our sun. The sun is no ordinary ball of fire. It's a colossal, violent furnace made mostly of hydrogen and helium gas, held together by gravity. Its diameter? Around 1.39 million kilometers. That's more than 100 times wider than Earth. Inside the sun's core, where temperatures soar to a staggering 15 million degrees Celsius, hydrogen atoms smash together in a process called nuclear fusion. This fusion converts hydrogen into helium, and in doing so, releases unimaginable energy in the form of light and heat. But here's the catch. The photons born in the core don't reach us instantly. It takes thousands, sometimes hundreds of thousands of years, for them to slowly work their way out through the dense radiative zone, bouncing, scattering, before escaping through the convective zone, and finally radiating out into space. Only then do these rays begin their 8-minute journey to Earth, traveling 150 million kilometers at the speed of light. Think about that. Every ray of sunshine warming your skin is the result of a cosmic journey spanning millennia. Can you imagine a star so vast and powerful, yet so delicate, that a single cosmic event could end its life instantly? What would you do if you learned tomorrow that our sun, this gigantic furnace of life, was about to be swallowed whole? Would you savor the light while it lasts, or prepare for the unimaginable darkness ahead? Now, meet the antagonist, the black hole. Black holes are cosmic monsters, born when massive stars die and collapse under their own gravity. Imagine compressing a mass greater than our sun into a tiny sphere, so dense and powerful that its gravity warps space-time itself. The key boundary here is the event horizon, the point of no return. Cross this invisible line, and escape is impossible. Not even light can break free. Picture a cosmic whirlpool. Anything caught in its pull gets stretched, torn apart, and swallowed whole. If you had the chance, would you dare to observe a black hole swallowing a star? Or would the terror of witnessing such destruction drive you away? What do you think happens inside a black hole, where all known physics breaks down? In some rare cosmic dances, black holes and stars come dangerously close. When a black hole edges near a star, it begins to tug on it with tidal forces, gravitational forces so strong they can distort and rip the star apart. This ripping is called spaghettification. The star stretches into a long, thin stream of plasma before ultimately being devoured. The star's gas doesn't just vanish quietly. Instead, it forms an accretion disk around the black hole, a furious ring of swirling matter heated to millions of degrees, glowing brightly in X-rays and gamma rays. Astronomers have observed such events happening in distant galaxies. But what if this happened to our sun? Imagine that slow, terrifying process unfolding above your head. The black hole drifts silently into our solar neighborhood, invisible, but its gravity announcing itself with an invisible, crushing force. At first, the sun feels a subtle tug, a whisper in the vast cosmic ocean. But within seconds, that tug becomes a violent pull. The side of the sun, facing the black hole, experiences stronger gravity than the far side. This difference, called a tidal force, begins to stretch the sun into an elongated shape. Imagine squeezing a water balloon from one side. The fluid inside strains and stretches, pulled taut. The sun becomes a glowing, fiery spindle. Picture the sun stretching, twisting like cosmic taffy. Can you imagine the immense power it takes to distort a star 1.39 million kilometers wide? What emotions stir inside you, imagining our life-giving sun turning into a dangerous sliver of plasma? Would you try to capture these last moments on camera, or simply stare in disbelief? The sun's outer layers start to peel away. Streams of superheated plasma escape, spiraling inwards towards the black hole's event horizon. This forms an accretion disk, a blazing, spinning ring of star matter, emitting fierce X-rays and gamma rays. For distant observers, this disk becomes brighter than any other object in the sky, a deadly cosmic lighthouse. Inside the sun, fusion reactions grow chaotic. Pressure drops in some areas, surges in others. The core begins to collapse, pulled inexorably toward the dark maw of the black hole. And at this stage, the physics is extraordinary. As matter spirals inward, it heats to millions of degrees due to friction and gravitational forces. The energy emitted is so intense, it can outshine entire galaxies in specific wavelengths. With the sun gone, gravity's anchor is lost. Planets, no longer held in orbit, shoot off in straight lines, tangent to their orbits. Earth, once revolving at 30 kilometers per second, hurtles into cold, dark space. No sunlight means no photosynthesis. Plants die. Oxygen levels drop. Temperatures plummet. Within days, Earth's surface freezes. Humanity faces a nightmare unlike any before. If Earth was hurtled into darkness and cold, would you try to survive underground, powered by artificial heat? Or would you attempt to build spacecraft to escape the dying solar system? What's your survival strategy when the ultimate source of life disappears? The instant the sun is swallowed whole, its gravitational grip on the planets vanishes. Earth, Mars, Venus, all lose their orbits. Imagine being strapped to a roller coaster that suddenly lets go of its tracks. You shoot off tangentially into the void. Earth hurtles in a straight line through the black emptiness of space at 30 kilometers per second. But now, no light, no warmth, just infinite darkness. Close your eyes. Imagine that moment. The sun gone. The sky doesn't glow. The familiar warmth evaporates. Temperatures plunge rapidly. Within a week, the average surface temperature plummets below -70 degrees Celsius or -94 degrees Fahrenheit. Most humans and animals perish. Imagine standing in the ruins of a frozen Earth. The sun swallowed by a black hole. Our once brilliant star, now a dark memory. The universe feels vast, cold, and indifferent. Yet here we are, the last sparks of life clinging to hope. Think for a moment. If the sun can be destroyed in a cosmic instant, what does that say about our place in the universe? Does it make life more precious or more fragile? Would you find meaning in the struggle to survive, or in the knowledge of our inevitable end? I want to hear from you. What do you think about this cosmic vulnerability? Would you build a bunker underground, try to escape Earth, or find peace with the inevitable? Comment below. Your thoughts might inspire someone else. All right, though the sun's hypothetical fate is terrifying, remember, our star has burned steadily for 4.6 billion years. It will shine for another 5 billion, giving life, warmth, and energy. This vast stretch of time is a gift and a chance to explore, to understand, and to marvel at the incredible cosmos we inhabit. If you enjoyed this deep dive into the sun's mysteries and its terrifying hypothetical destruction, please like, subscribe, and share this video so more curious minds can join this cosmic journey. Hit the bell icon to never miss an update, and share your survival strategies in the comments.